Hey everybody, Riot New here. Welcome to the VOD of our gameplay programming stream. In that stream, we covered all the basics that you need to get started writing game logic. We talked about actors and components. We talked about the blueprint editor, functions, variables, events. It's all here. With those basic building blocks, we built some garage doors. We built a pressure plate. We built wall switches that are networked together and update their state when the controlled garage door is moving. Lots of good stuff here. I hope you enjoy it. Make sure to like and subscribe if you want to see more of these videos. And if you want to participate in the live stream, I stream on Twitch. I'm Riot New every Tuesday, Thursday, Saturday, and Sunday. Enjoy. Tonight, we're going to talk about gameplay programming. The last Unreal stream we did a little bit of level prototyping. That is not a prerequisite for what we're going to talk about today. But if you want to see it, it is over on the YouTube channel. We have a nice VOD there. It's about an hour long. And you'll see how we built out the level that we're going to look at today. Let's get you all over to the right scene. So, the goal for this stream is we're going to talk about kind of all the basic pieces you need to start doing gameplay programming. We're going to be working almost entirely in Blueprint, which is Unreal's scripting language, but it is real programming. Let's clean up a few things from the last session. So first of all, I don't want to load into the template map. I want to load into the map that we built. So if you ever want to change that, over in your project settings, maps and modes is where you control what the game and the editor starts up with. And in our case, we're going to use our Ascent clone for both of those. And just to convince myself that that worked, I'm going to close the editor and restart it. We'll get that back up here. All right, let's fire our level up now, and we should load into the correct map. Yes, we did. Okay. And I recall at the end of our last session, I think we were spawning in the boxes. Yeah, we are. So let's fix that real quick. We're just going to tidy up a little bit before we really get going in earnest. So the way your spawn point is determined is by this little player start actor. And we're just going to move him away from those boxes and put him here. So a couple reminders for those of you that weren't here on the last stream or haven't played much in Unreal. A couple useful hotkeys. You can use the end key to drop an actor down to the floor wherever you're working. Another one that's super useful is you can hold the Alt key while manipulating a transform gizmo to make a copy of an object. So I'm going to make a little bit of additional floor out here real quick because we might play in this space a little. Let's see here. Let's do right about there, and we'll just pull that up like so. Maybe a little bit longer in this dimension. All right, so let's make sure we can play now. We can, and we have a solid floor. Great. And I have to go a little further to jump off our world now. All right, so what I want to do now as like our first gameplay programming exercise is I want to build the garage door that you're all familiar with on Ascent. So we're going to build a door. It's going to retract. We'll make like a pressure plate. If we have time, we'll also make a switch. And we're going to use this kind of like as an opportunity to go through all the pieces involved in that. So in Unreal, the level that we're in is called your world. This is a world, and a world has a ton of different actors. And basically every object in the game is an actor. So you'll recall last time we did a bunch of placing of blocks and things like that. These are all actors called static mesh actors, because really all they are is they're a mesh and a material, and they don't really do anything when the game is simulating. They're just basically just geometry and some art. Editor's a little laggy. Let's see if we can make this a little bigger. You'll also see my world. I've got other types of actors. I have like some lights in here. I have a reflection capture. What else do I have? When I create my character by starting the game, let's see if I can press the right hotkey here. Yeah, there we go. You're going to see all of these yellow actors are like temporary actors associated with my play session. So I have an actor for my camera. There's one for networking. There's one for my HUD. There's one for my player controller, which we'll talk about later. But there's a whole bunch of different types. And if you look at like what actually goes into an actor, it's pretty flexible. So if we look at third person character, which is that character that we're controlling, I can fire up the blueprint editor here. And what you're going to see over on the left is a bunch of components that make up the actor. So we've got a cylinder, we have a mesh, which is what that mannequin is. It's a skeletal mesh that we're going to be animating. We also have a character movement component, and the purpose of the character movement component is to contain all of the logic to move our character around and do the right replication and networking stuff, which we're not going to talk about today. But the high level idea that I want you to take from this is that an actor is composed of a bunch of different components, and those components you can think of as like capabilities for the actor. So this is an old Tumblr called UE4 Blueprints from Hell. And what you're going to see is, like, if you're not careful, you can get pretty out of control here and have a bad time. Most of these I think are jokes, but it's pretty fun. Here, let's see if we can find one that's wild, right? Like, so if you don't build your logic out of smaller pieces, you're going to end up in a world state where you have like these complicated graphs that are just impossible to reason about and maintain. So yeah, be aware of that. This would be considered an anti-pattern probably. I would not want to try and fix a bug in this logic. It'd be pretty rough. Let's start by building our very first actor here from scratch. We're going to build a garage door. Blueprint class is what we're starting from. Actor. We are going to call this BP garage door. BP is just for blueprint. We are going to go ahead and open this up, and you see right now we start with absolutely nothing except this little scene root, which basically gives us a position in the world. I'm going to put 2 static meshes on our actor to start with. We're going to have our door frame, and we are going to have the door itself. And then we will just position those, and you'll see what that looks like. I'm going to parent both of these on the scene root for now, and we might change that. But our door frame, we're going to just use those super grid boxes that we used to build our world last time. So great, now we have a box. I think if I look at our map here real quick, so you'll recall we talked about how each of these large segments is 100 centimeters. So we need to go 100, 200, 300, 400 centimeters wide and 400 centimeters tall. So to do that, I'm just going to adjust the scale on this guy. Let's go ahead and make him 4 units wide, and I think 1 unit tall and 1 unit long is probably, or sorry, 4 units wide, 1 unit deep, 1 unit tall. I think that's probably okay. We're going to move him up 300 centimeters. Yeah, 300 centimeters. All right. Now our, ooh, I did not mean to call that root. I was talking. I meant to call that door. All right. We're going to do the same thing for our door here. And we're going to make them look pretty here in a minute. So I'm just searching for super grid box because that's what I want to use for this. So same thing here. We need him to be 3 units long, and let's call it 3 units tall. Sorry, 4 units long, 3 units tall. All right. So now we have a frame and a door. The next thing I want to do here is I want to make this material different. So if you'll recall last time, we have all these super grid materials. We can create material instances, which we'll do in a minute. Right now, I think I'm going to go ahead and just make my frame the default black. So we have a black top to our door. And let's make this like actually, let's make him, do we have a white top? Yeah, we do. All right, so we have one out of the gate. So let's compile that. And then let's go ahead and make this silver. I'm gonna create a new material for that, I think. So let's just create a material instance off of the default super grid material that we picked up last time. And let's just call this like gray. All right, we wanna override the color here. And I think if we just make all of these something like that, it's going to be pretty dark. Let's tune it up a little bit, maybe something like that. There we go. That looks like a nice gray to start from. So now if I come and change the material on our door and I search for gray, we're going to see our new material instance, and we should now have a better looking door than that. Let's drop one in the world and see what it actually looks like. You know what? I don't like that. I don't think my I don't get enough of a distinction there. So let's actually go back to making the frame here black. Super grid. There we go. All right. And things look a little different in the viewport than they do in the game itself. It just has to do with like where they put the light. So you can see from this side, it's brighter than on this side. And maybe actually, since we're going to work from this side, maybe I should just rotate the whole thing. You know what? It doesn't matter. All right. But now if we look in the world, it looks a little bit better. Yeah. All right, cool. So let's go ahead and position him in the world, and then we can start figuring out what it's actually going to do in terms of gameplay logic. Y'all should feel free, if you have questions as I'm going, or if I'm going too quick, feel free to like stop me and ask. Like this is not a talk. This is us just hanging out, building games together. So feel free to ask any questions. The other thing that I think I want to do here is I want to give my frame a little bit more texture. I want it to like pop out a little bit. Can I do a Valorant character in a stream someday? That would be quite a bit more complex, but maybe someday we can do some sort of character. Let me make my frame a little bigger real quick here. So I'm coming back to this viewport view, which is where you put all of the pieces together. And really you only use this if you have meshes and such like we do here. So I'm just gonna add like an extra 10 centimeters on the X and Y dimensions. Oops, sorry, 4.1. And then I want to shift him by 5 centimeters, right? Is that right? That's the wrong direction, -5 centimeters. And then what about over here? I also need to come back -5 centimeters. Perfect. So now if we look at it, we've got like this little bump and we can see it sticking out from the wall a little bit. I think that looks a little better. Makes it look more like a door. All right, so that is our first step. Now, the next thing that I want to show you here is the blueprint editor itself. This is just the viewport where we put things together. We have two other things out of the box. The first is we have construction scripts. Construction scripts don't run during gameplay. They run before gameplay begins. They also run whenever you change a property on the actor. So this is useful if we want to do some form of setup and have it be represented in the world. We'll talk about that. We also have the event graph, and the event graph starts with 3 important methods. They have the begin play event, which is when your gameplay actually starts. They have actor begin overlap, which we're going to talk about later. We don't need that yet. And we have a tick function. And every frame of the game, if your actor has a tick function, that tick function will get called, and you can run logic. This is super useful, but it also can be really, really expensive because you're doing work every frame. So it doesn't matter with a simple project like this, but with a more real game, you're going to need to think about like, hey, what do I need to actually tick versus what can I do in response to like a player action? So something like inputs or movement, that all like makes sense to tick because you're going to update it every frame. But our garage door most of the time is going to be totally idle. It's not going to be opening or closing. And so we don't need to be paying any cost to tick it when we're opening and closing. Don't worry too much about this yet, but just like keep it in the back of your brain that when you're building out an actor, you want to think about whether or not your actor actually needs to tick. The other things that we have here is we have variables. Variables allow us to store state. If you've done any programming, it's exactly what you expect. We'll talk about it. You say every frame. Does that mean higher FPS? It will close faster. If you do a constant value every frame, it will. But the input to tick is this delta seconds, which is the amount of time that has passed since the last frame. It's not that the event tick itself is CPU intensive, Lucho, but if you think about, let's say I have 10,000 actors and they're all ticking, even if they're running a very small amount of logic, it just adds up whenever you do something 10,000 times. So let's think, like, let's say we were trying to build a game that was like Factorio or Dyson Sphere program. Like kind of the naive way to build that is like you could have every factory ticking to update its inputs and outputs. You would probably get really bad performance with that. So probably what you would want to do is find a way to batch all of that logic, and only when the player's like inspecting how many materials they've created, do the work to do that computation, because stuff like that you can kind of compute on demand. So if you can figure out a way to compute what you need on demand rather than having to simulate it every frame, you're going to get better performance overall and less load on the CPU. All right, so that's kind of how the blueprint editor is laid out. I mentioned you can do stuff in the construction script that runs before play begins. I'm going to show y'all a picture which I don't want you to get scared of. So don't get scared. This is the life cycle of an actor. There are a lot of stages. You do not need to know everything here. You don't need to memorize it. I don't know every box. I can't create it from memory, but it is a super handy reference. And this is just on the main Unreal Engine documentation page. So if you're ever like, hey, what are the steps in an actor's life cycle from its creation to its destruction? This is a super useful graphic. Construction scripts run here. So they run very early in the flow relative to begin play or relative to ticking. So it's a good opportunity to do something early. So let's start by writing a construction script. I think what we want to do is we want to allow a designer to control whether or not the garage door starts open or closed. All right, so how do we go about doing that? Well, first of all, let's go ahead and create a variable and let's call it B starts opened. It'll be a Boolean variable, so it's either true or false. And in Unreal, the convention for Booleans is that you prefix them with a B, which just stands for Boolean. It's not that clever. A couple things, this variable should be public. We should be able to see it outside of our internal blueprint here. And we want to be able to make it instance editable rather. So what that means now, after I compile this, and let's actually also give it a category. Let's call it just door as our category for now. And you'll see that puts it in like a little mini folder here that we can expand and collapse. So now if I click on my door actor, you can see I now have a checkbox here that says starts opened. And by default, it's unchecked, but I can check it to open and close it once we write that logic. So how are we gonna actually do that? Well, there are two ways that we can move this door around that are pretty straightforward. The first way is we could move the door up. So like we could literally just kind of drag it along and pull it up into the wall. The other thing we can do is we can manipulate its scale. So if we make it have scale 0, it basically disappears. And in fact, I want to flip it 90 degrees, I think, or 180 degrees rather, so that when I manipulate the scale, it goes up and disappears. And like, obviously this is not exactly how a real door works, right? But like, we're making games now and games are full of lies and tricks. We just need something that looks good. So if I were to make the scale 0 here, our door disappears and we just have the frame, right? So we're sort of creating the illusion of the door going up. We get a little bit of Z-fighting here, which we should be able to fix, I think, if I make this a tiny bit taller and drop it 10 centimeters here. That ought to work. So let's go back to our door here. And if I go back to my full length door, door is extended. And again, if I make it 0, it goes away. So let's go ahead and write the code to make that happen in our construction script whenever that checkbox changes. So first, we need to keep track of how big the scale needs to be when it's fully extended. We know that's 3, but we can also just save that value. And this one, let's call it closed scale Z. And this can be a float. So a float is just a numerical type that has decimal precision. So if I compile again so you can see it, I can be 0.0, I can be 2.5, I can do whatever. It's actually 3, but we don't need to actually save that here. We're gonna have the script do it. So let's begin by doing get scale, or hold on a second. Let's pull the frame in. So we're gonna access our frame and we're gonna ask, what is the scale of the frame? Get relative scale 3D, I think is the one that we need. Why does Z-fighting occur? It's when there's like pixels at the same depth, and it's a common thing in rendering. But basically there are 2 pixels that are the same depth, and so they just get picked randomly. All right, so we have our scale object here. Scale is a vector, which is basically 3 floats. It's an X, a Y, and a Z, just like what we see over in our scene view. If I right click here and do split struct pin, I can get to all of the individual pieces. So the very first thing we're going to do is we are going to set our closed scale to whatever it's set to. And the reason we're doing this is if I now go and change door, like let's say I make a big door and I make this 5, when the construction script is called, it will remember that it's a 5 versus a 3, and we don't have to remember to update it. I also can make these static because they're not actually going to be moving here. All right, So we're continuing to work on our construction script. The next thing we want to do is ask whether our designer said it starts opened or not. We only need to do something if they said it should start open, because by default we're starting closed and we're already in that state. So the next thing we're going to do is we're going to do a branch operation. With a branch operation, all we're doing is we are checking if a Boolean or an expression is true or false. And if it's true, we're going to continue. And again, we're going to take our, ooh, I didn't mean frame. This should be door. That would be a fun bug. Let's fix that real quick. All right, we're going to take our door again here. We're going to bring it over here and we're going to set scale. Set scale 3D. When true. And we are going to take our previous values. We're going to keep the X and the Y. All right, so another thing you can do, Blueprint gets pretty spaghetti looking, but you can double click to add this reroute node, which allows you to do a little bit neater layout here. So I'm just going to move these down here so we can see what's going on. And then I'm going to put this in a variable, even though I don't think we're actually going to use this, because I think our open scale is always going to be 0. But let's go ahead and track it in a variable just in case we want to play with it later. So this is going to be opened scale Z. It's also a float. Great. I think we're done. Let's see if this actually works. If not, I'm going to be embarrassed. Hey, it works. So now when we click this checkbox, a designer can come in here and say, hey, I want this garage door to be opened or closed. And the reason that this approach is cool is, let's say I clone it. I have 2 garage doors. I can configure them independently. That one's closed. That one's opened. This one's still closed, right? It's just a setting on my actor. All right. So now we've got a basic construction script. And as I mentioned, you know, this runs whenever we change the setting. This runs before play. It shouldn't cost anything in the game itself when the game is up and running. But what we want to do is we want to make it so that this door can actually animate. So let's think about how to do that. Well, I mentioned that ticking's expensive, but I think for the purposes of this setup, we're gonna begin with ticking. The other thing I want to show you is you can create what's called an enumeration, and let's find where that is. Is it here? Yes. You can create an enumeration, and we're going to call this garage door state, because really there are 4 states I think we want to think about for the garage door. There is closed state. There is a closing state. So this is when we're going to be moving into that closed position. There's an open state, and there's going to be an opening state. And by creating this enumeration, I basically now have created a type that I can go and use. I have a lot I want to show you. And so we're going to maybe take a few shortcuts, but it's going to be effectively real. It'll be good. All right. So the next thing that we're going to need here is we're going to need to keep track of what state we're in. And I'm going to do something to make you happy here in just a minute, Lucho. So let's call this current state. And we're going to change the type from float to our new enum type, which is eGarageDoorState. And again, we're going to put in that door category. So this is also private. No one else needs to be able to see it for now. But what we can do here is we can say, let's get our current state. Let's do a switch on its state. And now we get little execution pins for all of those different states we just talked about. And since we want to be performant and not make Lucho sad, if it's closed or opened, we can stop ticking. I think there's an easy way to do that. Set is an actor tick enabled. The other nice thing about Blueprint that you don't get in C++ is you get this nice search bar and you get context sensitive search based on what you're dragging from. All right. So if it's opened or closed, we don't have anything to do. We'll just stop ticking. Another thing you can do here is you can set breakpoints, just like with a real debugger in a real programming language. The hotkey for that is F9. Let's see where it is in the UI. Well, first let's compile. So what the behavior you're going to see here, I'm going to start in state. I need to start my state based on my construction script, actually. So if we start open, we need to set current state to open. There we go. That'll work. And then otherwise, we're going to have it default to closed. So what you're going to see here is this node that we just put in is only going to get called one time, because after our very first tick, we're going to turn ticking off when we call this. So if I run the game now, what you're going to see is my breakpoint gets hit. It says, hey, I'm coming through the closed pin. And if I resume, that breakpoint's not hit again. And now it's not doing anything. So there we go. You could use a timeline. I'm actually not going to use a timeline for this. We're gonna do it all manual. We're doing it old school because I think that's useful to just think about how to do this type of stuff. So if we're closing or opening, we actually have work to do. And if we think about what that work is, when the door is closing, we are moving towards the closed scale Z that we set up in a variable. If it's opening, we're moving towards open scale Z, which is always 0. And right now, closed scale Z is 3.0, but could theoretically change. So each frame, we want to move by some amount towards those targets at some amount of speed. And for now, let's just assume that the full movement of the door is 1 second long. So what we need is the direction that we're moving towards, which is the scale. So it's going to be closed scale Z times delta time is going to fully open in 1 second. So if my delta time was 100 milliseconds, I am going to move 1/10 of the way there, which is 0.3 units, right? Does that math work? Am I doing it right, chat? Let's double check here. Where's my calculator? Here we go. So 3.0 times 0.100 is 0.3 units. Excellent. That's exactly what we expect. The next thing that we need to do after we figure out how much it moves is we need to determine, like, hey, have we hit our target? Like, if we are at 3.0, we need to move from closing to closed, and we know that we're done. So we can also talk about how to move in a time to actually. All right, we're gonna be more flexible than hard coding it to 1 second, but we'll come back to that. Let's start with this. So this is our goal. We just want to be able to animate that movement. The other thing we're gonna need is we're gonna need to be able to drive that movement. Let's maybe write the code to start and stop the movement first, because we're gonna need that. Let's create a new function, which is just like a little ball of logic, and let's call it toggle state. And I think this is going to be pretty easy to write. If we come back here and if we copy this switch, because I don't want to search for it again. If we are closed or closing, we want to set our current state to opening. And if we are opening or opened, we want to set our current state to closing. Right? I'm having trouble dragging a pin, but it will get there eventually. Then we need to set actor tick enabled, because we need to actually run the movement logic that we're going to write. But we now effectively have the ability to toggle the current state of the door. So if we're closed or closing, we move into the opening state. If we're opened or opening, we move into the closing state. Does that make sense? Are y'all with me so far? Exactly. You're toggling it so that you move to the opposite state. So now we need to actually go and compute how that movement is going to happen. I'm going to go ahead and create another function. We're not going to implement it yet, but let's call it get movement amount. It's going to take an input, which is going to be that delta time. And it is going to return another float, which is movement amount. I guess we can call it delta movement. It's called movement amount. All right. Now, right now, this is clearly wrong, but let's just have it start with delta time, because that will get us some movement, and then we can actually implement the real logic here in a minute. So let's come back here. We are going to call our get movement amount function, and we will feed it delta time. It's going to give us a number back. We need to clamp this value between our minimum and maximum values, which are open scale Z and closed scale Z. Closed scale Z, you'll recall, is actually our maximum because it increases as we close, and open scale Z is always 0, but we're going to create a variable, just to be safe here. The other thing I can do here, if your blueprint function doesn't change state on the class itself, you can mark it pure. And I think this function can be pure because it's read only. And the advantage that a pure function gives you is you don't have to connect an execution pin to it. It can just read the state and move on with its life. All right, so we get movement amount. We're clamping it so that we know that it will end up at most open scaled Z or closed scaled Z. Then we need to actually do the scale adjustment. And that scale adjustment is going to look almost identical to what we did over here in our construction script. We're just going to adjust that Z value. So we have our door. We are getting our relative scale. And then we also need to set our relative scale to the new value. We are going to need to add. I left out a step. We actually have to add to our scale here. So we take our current scale and we are going to add it to the movement amount. Just like so. Got a little bit of addition. Then we do the clamp on the final result. Then we set the X, we set the Y, and we set the Z. Easy as pie. Oops. So a couple more shortcuts that are useful to know. If you want to disconnect a pin, you can hold Control. You can also hold, I think it's Alt, to just delete a connection altogether. And as I mentioned, you can double click to create these reroute nodes. So we're going to do that real quick. Bring these down here. Let's make another one. And another one on that line. I can't get to it. Okay, there we go. And we'll clean this up a little bit here in a minute. All right. So if we are closing or opening, we want to set relative scale. And right now, our math is wrong. We already talked about that. That's fine. We're going to figure it out. Let's clean this up just a hair. Bring that up there. The other thing we need to check is, hey, are we actually done? So I'm going to create another function for that. I'm going to call it end movement if done. I am doing a linear animation, but you can do a curve, and timelines are really good for that. Timelines are basically a way to set points on a graph between 0 and 1 and then use that as a multiplier. But I wanted to show you all how the math works here, which is why we're doing it by hand. All right. So the last thing we need to check is whether movement's done. And to do that, we're going to use this function that we wrote, but haven't actually implemented. And I think that's it. The last piece that we need is, for now, we need some way to actually cause the door to move because we haven't built a switch. For now, I'm going to take a hacky approach and we're going to come and clean this up. So this is not a good pattern, but this is a good way to quickly debug something. You can turn on input for any arbitrary actor. This is not the right way to do input in Unreal, but it is a good way to test something. So I can say auto receive input from player 0. Since I've only got one player, that's me. When I press the F key, I'm going to toggle state. Now, I think what you're going to see here when I play this game is toggle state is going to cause it to move, but since our movement amount math is wrong, it's only going to move in one direction. Oh, let me remove our breakpoint from earlier. Uh-oh, it's not moving at all. Why is it not moving at all? All right, well, let's debug and find out. So when I press this key, we should be calling toggle state. Let's make sure that happens. That does happen. Great. So if we step into our function, let's see what it's doing. We have a current state value of closed. We're going to set it to opening. We're going to turn on the tick. So the next thing that I expect to happen is our tick function should get called again here. Let's see if that happens. It does get called again. Since we are opening, we're going to move into set relative scale 3D. Let's get a breakpoint there. And then what are we setting? Oh, well, we're setting the value to 3 because we're always increasing and we're always clamping. So what's happening here is we added our delta time. So can you all see on my screen here, the 3.4? you can inspect the pin here to get the values, but we're then clamping it back down to our maximum value, which is why we don't see any movement. So my quick hack to prove to you that we are actually calling the code that we expect to be calling is, I think if I just flip this door to start open, you're going to see it close down here. Let's kill our breakpoints again because we don't need that anymore. We did our debugging. Yeah, so you can see now it closes, but I can't reopen it. So now we need to do the actual math here. Let's begin by looking at what we wrote before. Close scale times delta time is what we think it is here. So to do that, we just get our close scale Z. We have our delta time already. We do a quick little multiplication. What would happen if I rapidly pressed F? I will show you as soon as we have it actually functioning. But the answer is it will toggle back and forth between my two states. But it'll make more sense when we can see it. All right, so now our movement amount is going to be a full movement, open or closed, in 1 second. And the delta time is the relative amount that we're going to move each time. The next piece is we need to figure out the movement direction. And if we're closing, it's going to be increasing because we're adding scale. If we are opening, then we're going to be decreasing scale. Because remember, when we're closing, we want to be moving towards 0. Or sorry, when we're opening, we want to be moving towards 0. And when we're closing, we want to be moving towards 3. So we, again, can look at our current state and figure out which mode we are in with that switch statement. Also, we shouldn't be called if we're closed or opened, but let's assume for the sake of argument that we are. In that case, we're just going to return 0 because there should be no movement. So this should never get called when closed or opened, but this is just like a good defensive programming guard to have. All right. So if we are closing, we are increasing the scale. And if we are opening, we want to be going the other direction. So let's multiply this by another float, and our float here is just going to be -1. All right, I will clean all this up so that y'all can better see what's going on. So if we're not moving, the movement amount is 0. If we are closing, the movement amount is increasing. If we are opening, the movement amount is decreasing. And we get that by just multiplying the movement amount by -1. The other function that we need to implement, I want to clean this up a little more. I still don't like the way this looks. So there's a plugin that I'm not using that makes your graph look a lot cleaner. I'll show that in another video. It's not free though, which is why I don't have it enabled right now. It costs like $10 or something. Okay, so I think we have movement implemented now. If we come back to our event graph, what else do we need? We need end movement if done. So again, the way we do that is we're going to look at our current state and we're going to do a switch statement on it. And if we are closing, we want to check if we are close to being done. Let's get our door. We want to get our current scale 3D again. We want to split it out again. Why can't I split it? There it goes. We want to say is nearly equal. Actually, I don't want nearly equal. I think I want to say greater than or equal. Is nearly equal because we're clamping, right? Nearly equal. So floats accumulate error, so you can't just do a straight equality check on floats. You always need to check if it's within a close range. In this case, we're going to check if we're within 0.000001 units of our target here, and we are comparing to our closed scale Z. Hang on a second. So the return value of that is going to be a branch. So we're going to write this code. If we are closing, we want to check if we're nearly there. And if we are opening, we want to check if we are nearly open. So let's do this, and our open scale Z, like so. And again, we're going to need another branch, and we're going to move around all the spaghetti here. This is one of the downsides to visual scripting compared to like just writing code. It's much easier to lay out text in a way that is straightforward to reason about. All right, so if we're opening, we're checking if we are near our opening point. Let's move all this down here. And in either case, we need to set to our new state, right? Let's bring all this back. All right, so if we're closing and we are near our closed target, we can set current state to closed. And if we are opening, we can set current state to opened. At which point, the next time we go through our tick function, it's going to turn off our tick and we're not going to do anything. So now I think everything is going to work, but I want to tidy up a little bit here. In movement is done is our gross looking function here. Let's position that like so. We've got our nearly equal calls. That's looking a little better. Let's put this guy here. Maybe like so, and maybe like so. And we can make these guys a little cleaner by changing the order they're in, because since it's an equality check, it doesn't matter which one's A and which one's B. Then we'll line these up. I'm OCD about my spaghetti. It's just like my conveyor belts in Dyson Sphere program. All right, I think that'll work. Let's play our game and see if it works. So now if I press the F key, it closes and it opens. And if I press it quickly, it toggles between our two states and starts moving in the direction. So we have a functional door, y'all. We have a functional door. All right, now the next piece that we need is just like one little modification. So if I stand in the door and close it, it's going to have collision. And like, we're just not going to fix that right now. That's okay. That's easy to fix if we want to fix it, but it's not something that we need to fix. And in fact, I think if I start it down, it might block on the character. Yeah, so it pushed the character out in this case. Now I'm stuck inside the door. All right, the last piece that I want to do on our door itself before we start actually wiring it up to stuff. Okay, I'm going to come back here and I'll check chat in just a minute. What did I want to do? I want to do movement speed, right? So let's give our designers another tunable. So all we need to know is how much do we want to move it per, like, what is the time period it takes to fully open or close the door, right? So like, let's say I want to make that 3 seconds. Movement time. Movement time in seconds, let's say. And in fact, I'm going to drop the in and just call it movement time seconds. And we're going to make that a float. And this one is going to be configurable by our hypothetical designer. So I'm going to just move it there. And I'm going to click the little eye so that we can see it here. I need to compile so that I get a default value. And I'm going to make it a 3 by default. Now let's think about the math here. I need to transform our movement speed based on this time. So I think what I actually need to do, right now we're tuned for 1 second. So what I need to do is I need to divide this by 1. Or I need to divide 1 by this time, rather. We want float division. So let's divide 1 by this value. Now we also now need to make sure that this value is positive and not 0, because you can't divide something by 0. Can I specify a clamp value here? I can. So let's set this to 0, 0.1, .01 rather, as our minimum value. And then it shouldn't be able to be 0 or negative. And we can test that in a minute and make sure that's actually true. Then I think the last piece we need actually is just another pin. I should be able to add a pin. There we go. Yeah, so we'll just multiply it by that. So now what is effectively going to happen is if I say I want a 3-second movement time period, then this multiplication is going to get multiplied by a third. So it'll slow it down by a third. If I set it to 0.5, then 1 divided by 0.5 is 2. So we're going to double our movement speed. Never divide something by 0. Not a joke. Exactly. All right, so we've now got our movement time here. I'm going to go ahead and go back to starting opened for the sake of looking at this. And what you'll see is now at 3 seconds, it moves quite slowly, which is what we'd expect. If I set it to 0.5, it's going to move quite fast. See? We can decide what is right for our game. For the sake of testing, yeah, if I try and put 0 in, it moves it to 0.01, which is basically instant. That's going to be like, a couple ticks at most. I could make it smaller, but that looks good enough to me. I also want to make sure it doesn't let me put in a negative value. It does not. Perfect. All right, y'all, we have a functional door. So now the piece that's missing is what is actually going to call that toggle function that we wrote. Because right now we're using this hacky F key press, right? Which we're not going to use. So we need something to actually control our door. Let me go ahead and turn off input as well, because we do not want our door taking input. We also should have reasonable performance characteristics, Lucho, because we turn off of our tick when we're not moving. So we're only ticking when we're moving. And whenever we toggle our door state back on, we turn the tick back on so that we can do the movement. So our next piece is going to be implementing a button. That's exactly right. Let me think here for just a moment. We are going to do a pressure plate first. Let's do a pressure plate first. And that is going to be another actor blueprint. We'll call it blueprint pressure plate. And I think actually before I create the actor, I'm going to create a few different materials here. Oops, this is why I do 2 content browsers, so I can flip around. I want a light green, a light yellow, and a light red. So let's create those really quick. Super grid, light red. Light yellow. And before I get too far along on implementing a pressure plate, does anyone have any questions about what we've done so far? Does this all sort of make sense? If not, I am happy to talk through anything. I'm going to set up these materials and I'll get caught up on chat. Let's see. And then I wanted a light green, right? Yes. Cool. We've got our materials, and this is going to be useful because we are going to make our pressure plate change color based on the current state. Hey, what up, Nicky Woo? Imagine the code behind the Ascent door now. Yeah, I mean, like, we're basically building it. The main thing that we're not building is we're not doing networking. We might do networking in another stream later, but networking substantially complicates the world state. Can you explain the toggling math, please? The toggling actually doesn't have any math. The toggling is just saying, hey, do we want to be opening or closing right now? Do you mean how we do the movement amount math? So remember, delta time is in seconds, and it is the time since our last frame. So usually this is, unless something's going really wrong with your game, this is going to be a fraction of a second. Closed scale Z is the total distance that we need to move. So if you think about having a movement period of 1 full second, then delta time, which is in seconds, times closed scale Z is saying, what percentage should I move in this frame against my 1 second target? Then the movement time seconds just allows us to manipulate that by dividing a second by our target. So if we say instead of 1 second, we want 3 seconds, we move at 1/3 speed. If you said we want 5 seconds, then 1 divided by 5 is going to be 1/5 speed. And when you multiply that all together, you get the total amount that you need to move. Then the last piece of the math is if we are opening, we are decreasing our scale. And if we're closing, we're increasing our scale. So if we're decreasing our scale, we need to be moving towards 0, which is what the -1 is for. So if you think about each piece, it gets simpler. Sadly, like there is some math in game dev, so you do have to sort of think these things through. But if you can break down each piece, you can sort of see why we're doing the math that we're doing. Does that make sense? Cool. All right, let's go ahead and build our pressure plate. This, I think, is actually going to be quite a bit easier than the door movement. There should be less math involved, at least for us. Unreal will do most of the math on our behalf. So we come back to our pressure plate here. Instead of my viewport's so fast. Let me slow that down. When you're flying around in your viewport, you can scroll forward to move faster and scroll back to move slower. So that's another thing that is super useful to have. But let's go ahead and add another couple static meshes. We're going to do like a standard circular pressure plate. So I'm going to use that super grid cylinder full, I think is the one I want. I think that's right. I'm inside it. That is obviously way too big. Let's go ahead and make it like a 1/10. That's still bigger than I want. Let's make it, what is that? That's 5 centimeters tall. That looks pretty good, I think. So 1 by 1 by 0.05, great. And let's make our base be super grid black, I think. All right, so we're gonna set that to our default black. We are then going to, let's call this space. Let's go ahead and copy him, make another one. Let's call this plate. And let's make him sit on top of the base, maybe. Since he is at 0.05, we need to adjust our snap to get it lined up, just like so. And I'm gonna make him a little bit smaller. Something like that, I think. Maybe a tiny bit bigger. Let's try 0.85. All right, so we have our base and our plate. And by default, let's actually have this guy have a green material. Light green is what I want. All right, so that's our pressure plate. And we're going to say, hey, the light green means we can interact with it. Actually, I want to do the light red, I think. And we'll have it turn green when you interact with it. So the last piece we need is we need to figure out how do we know if a character is standing on the pressure plate. And the way you do that in Unreal is with a collision volume. So out of the box, we get a box collision value, a capsule collision value, and a sphere collision volume. Since we are a circle, we're going to use the sphere. We set the radius of the sphere, which I think is going to be around 85 centimeters. No, around 42 centimeters. Sorry, radius is half the distance. And our scale here is 85 centimeters. So I'm actually going to make this a tiny bit bigger, maybe 44 centimeters. That looks pretty good. Yeah, that's close enough. So this sphere is completely invisible. We can see it when we're setting up the level, but players won't see it. So when I'm playing, you can see I just have the button, right? I don't have that sphere sticking out of it. Let's put him there. And what we use that collision volume for is whenever something is on top of it in that volume, we can trigger a behavior. So if I come back to my pressure plate, we're going to go into the event graph. And this is where we start caring about begin overlap. I don't need these actually. What I care about is, are you colliding with my sphere? Let's call it sphere collision or collider. Let's call it collision. You kind of wonder how Portal 2 button works. You mean pressure plate? I bet it does something very similar to this actually. I want on component begin overlap. Is that right? I think this will work. And I'm also going to need on end overlap. All right, so begin overlap means something came into it. End overlap means something left it. So for now, what we want to do is we want to check, hey, is the thing that entered here a character? Which I think for us, we can do any character actually. And if we wanted to support like boxes or something in the environment, we would change this logic a little bit, but this should be fine for now. So when a character enters, let's start by, for now, we're just going to change our material. So let's create two material variables and let's say active material, and let's make this type material. And we will compile that, and we're going to set our default value. What did we say? We said we wanted the light green when it's in use, right? Light green. Why is this not working? Super grid. Light. Am I crazy? Oh, I know what the problem is. I did material. I need material instance. That's why. Everything's fine. I'm like, why can't I find my material? So now if I search light green, we ought to see it. No, okay, I'm crazy. I don't know what's wrong, so we're gonna cheat. Let's go ahead and just delete this. We're gonna create a new variable and let Unreal figure out the type for us, and it'll be fine. We want to change the material of the plate. We want to do set material. Then I want to promote this to a variable. And then I want to compile. I want to make this light green. This should work. Yeah, I don't know why that previous one didn't work. Doesn't matter. I was setting the wrong type. But we can let the engine figure out what the right type should be for us. So let's call this active material. And then let's go ahead and create a copy of this, and let's call it the inactive material. So we're going to set this one to red. We're going to set the other one to light green. Great. So when something enters, if it's successfully cast to a character, so if it is actually a character, it's going to turn our plate to be light green. Let's double check that that works. Hey, it's light green. Huge success. Now, when I leave, it doesn't turn red because we didn't write that code yet, but it's the exact same. So we can just copy and paste and change it to inactive material instead of active material. Now, the next piece is we actually need to control the door. So somehow, oops, I have a blueprint compiler. What is it? What is it? It is that I forgot to plug in the actor to check if it's a castable to our character. So it turns green, we walk off, it turns red. I think my pressure plate's not quite big enough, so let's go ahead and make it a little bit bigger real quick. I could do this on, hang on, let's get into our viewport so that we can actually see the changes that we're about to make. So I'm gonna make the scale on our base here 1.5 by 1.5. We'll keep the same height, and then let's try making this like 1.35 and 1.35. And then we're also going to make our sphere a little bit bigger here. That's probably going to be like 60 something. Let's call it 70 for now. Yeah, it's a little too big. 68. 68 looks pretty good to me. Let's test it again. We now have a bigger pressure pad. Great. Red, green, easy peasy. Is this how hitboxes got so thick in Valorant? Character hitboxes are more complicated, but the general idea is characters have a capsule, and then we do collision tests against all the individual bones, and based on what bones were hit, that's how we compute damage. So if your hit is on the shoulder blade, that's a body shot. If it's on the kneecap, that's a leg shot. If it's on the head, it's a head shot. But it's more complicated than just a sphere collision. Hey Judy, how are you? Okay, so the next step is how do we wire it up to our actual door, right? Because what we really want to do here in our overlaps is we want to call toggle state when we step on or step off. So to do that, all we need is a variable, which is the door that we're going to reference. So let's look for our garage door type. My editor's hanging. BP garage door. Perfect. So we're going to get an object reference. We don't need an array. We just need a single one. We'll talk about arrays later, maybe. So we can only do this if the garage door is valid. So let's go ahead and move this out here and make sure that we have a valid garage door. So one of the nice things about Blueprint is if you write C++ that tries to access a variable that is null or not set, your game will crash. The Blueprint editor will actually protect you from that. you'll get an error in your logs. And in fact, here, I can just show you. So let's wire this up without a check. Oops, that's not what I wanted. All right, well, hold on a second. So we need to toggle state. Where we're going is basically just to toggle our state here. So let's actually pull this to the end for now. Let's bring this back to where it was. We're just going to restore what we had before. We're going to pull that out. All right. So we're going to say when we step on, we want to toggle state. And when we step off, we want to toggle state. And what you're going to see happen here is it's not going to work because I haven't set garage door yet. We will set that. But let's go ahead and expose this variable so that we can set it here in a minute. And I'm going to put it in a category pressure plate. Great. So I'm going to compile my blueprint. I'm going to press play. What's going to happen is the door is not going to get controlled and the game's going to get mad at me. So if I close here, you'll see blueprint runtime error, access none when trying to read property garage door. And then it will point to where the error was. And the reason it's an error is because right now my garage door is not set to a garage door. It is a null variable. And if we were writing C++ right here, the game would have crashed. So one of the nice things about blueprint is it protects you from that. That said, what we want to actually do before we do anything is make sure we have a valid garage door. And if we don't have a valid garage door, then we're not going to run any logic. So we can use a check called is valid. And this will basically just say, hey, do I have one of these? And if we don't have one of these, we'll just stop execution. And that also means now we won't change the material. Let's put this here. I hate my spaghetti, y'all. It offends me. Let's do that. That looks kind of okay, maybe. Looks not great. I'm going to go ahead and delete this for now. We'll talk about it in a minute. Okay, so I also need a validity check up here. Same thing. We only want to do work if it's valid. And let's also get a reroute node here so that we can sort of see what's going on. If I was not on stream, I would probably lay this out all beautifully behind the scenes, but we don't need to worry about that. So now what you're going to see is since we don't have a garage door, we're not changing the color anymore. Great. That's exactly what we expect. Now, the final step is we need to actually call that toggle function. So what we want to do is we want to call toggle state here. And since toggle state just toggles between opening and closing, we don't need to do anything fancy here. After we change our material, both of them can just call this. So to review, what's going to happen here is when we have a collision with that sphere, we're going to check, hey, do I have a garage door set? If so, we're going to check, is the thing that is stepping on me or is no longer stepping on me a character? If so, then we're going to change the material to either the active or the inactive material. And finally, we're going to toggle the state on our garage door. The other thing I want to do here is I want to make it super easy to see when we don't have a garage door hooked up. So if my garage door is not set in the construction script, we are going to run an additional bit of logic. And so this is going to work very similar to like our open closed starting state that we put on the door itself. If the garage door is not valid, let's copy one of these unhooked material, we'll call it. And let's put our unhooked material, let's make this the default black. Default black. There it is. All right. So if it's not valid, we will set the material on the plate just like we do for the light green and the light red. But in this case, it's just going to be black, which is going to be a pretty good hint that we're misconfigured. So let's give that a shot. And now if we look at it, you can see it's black, which means it's inactive. It's not wired up to anything. So how do we wire it up? It's easy. Well, since we created that garage door variable, now all we need to do is select our garage door. Now it's wired up. Now we have a pressure plate. Hopefully this works. I think it will. Yep. So as soon as I leave the pressure plate, the door goes back up. It will work for anything you put over it. Magabu, the reason I'm doing that is there are like multiple components on the character, and I just don't want to think that carefully right now. So if multiple components have collision with the sphere, what you might see is the enter and the leave is no longer sufficient. I'm just simplifying my world state. In a real game, let's say we wanted to say, hey, you could put a box on it. We would need to keep track of everything that comes in and everything that leaves. And as long as there's one thing remaining, it stays active. Does that make sense? So like, let's say I had 3 boxes here and then I removed 2 boxes, we would still want the pressure plate to be down. And our logic is not currently robust enough to handle that, because what we're doing is as soon as anything leaves, we do the toggle. So this is really just a sanity check to make sure I don't have 2 components or something to worry about. All right, my friends, we've now got a pressure plate built. I think the next thing we want to build is a wall switch. And I want to use the wall switch as an example of like how to do interaction properly. Your smooth brain is melting. You're all good, Jack. You're all good, my friend. So I mentioned, you know, we're writing all of our logic basically directly into the actor right now. And with more complicated actors, I think what we're going to want to do is put that logic into components. And if you think about a wall switch, right, you can press a wall switch and it can do all sorts of things. It can turn a light on, it could move a pad, it could call an elevator, it could open and close a door. So for now, we're probably going to bind to a door directly, but we're going to look at a pattern of like how you can start to make that logic reusable. We're going to take that autosave here. Is some of this logic the same for Killjoy's alarm bot when it activates when an agent comes in its radius? Pretty similar, Pat. I actually don't know exactly how that is implemented, but I would not be surprised if it has a hidden collision volume, and at the moment somebody enters it, it turns on and then it tracks. That's actually a good question, because you don't necessarily have to have visibility here. Let's say I made my sphere collision huge. Let's come here. Let's make our sphere collision like 300 units and take a look at what that looks like. Oh, that's not big enough. I want to get through this wall, I think, with my collision here. Let's try 800. That ought to be big enough. Okay. So now, if I even get there, my switch is going to activate because the collision doesn't care. Like, it doesn't actually map to my switch. See, now I have to get pretty far away. So you could imagine, and similarly, like I can go through walls here, right? My collision doesn't care. It just cares if I'm within the bounds here, right? So I have no visibility to it. It's not checking visibility. It's just checking, are you in that sphere? And so I'm not saying that's how that ability is implemented, but like it could be implemented that way. And if you didn't want it to activate around walls, then we could deal as like, okay, I need to have the collision and I need to have line of sight to it. So like that scenario is more complicated, but you can sort of see how the pieces come together. And I'm not going to show it today, but like doing a line of sight check is like fairly simple. Unreal has a lot of functions that basically say, hey, can I see you from point A to point B if I draw a direct line? And we can do that sometime, but I think if I do that today, this is going to run too long. All right, so let's make sure I get my sphere back to something reasonable. 68, is that what I wanted it? Yeah. All right, great. So let's go ahead and create a wall switch. We're gonna start from our pressure plate and just change it. Wall switch. I'm gonna do a few things here to make it different. So first, I don't want a sphere collision anymore. Yeah, I don't care. And I don't care about any of this. We're gonna delete this logic. We don't need it. We're gonna write new logic here in a minute. We'll keep the garage door binding for now. I don't know if we'll remove that in this one, but we can talk about it. Let's do our viewport edit here. So we don't want it this big. Let's make this much smaller. So let's make our outer one here like 0.25 maybe, and 0.25. And then let's make this one like 0.2 and see what that looks like. Yeah, that looks like a switch. I also would like to rotate this 90 degrees, I think, because we're going to be putting it on a wall. And I'm going to have to reposition stuff because I rotated it. That's okay. Let's get it like so. Does that look right? Did I do it right, chat? That looks like a beautiful switch. Where is my scene root here? This is where my pivot's going to be. But let's put one of these in the world and see what it looks like. See if it's easy to manipulate. And I guess what I could actually do to make the scene root disappear is I could make the base of my switch the scene root. Let me show you how to do that. So let's make that the scene root. And now I'm going to need to reposition this relative to the scene root. Okay, you know what? I've decided I don't want to work that hard. We're just going to make the scene root visible for now. Oh goodness, everything's a disaster, chat. When I play the game, it should disappear, right? Yes, it does. Okay, cool. We have a switch. That's what we were looking for. We went down a rabbit hole. Yeah, it's visible because I didn't get rid of the scene root. And what I should do is I should build things around my base mesh rather than the default scene root. But I forgot to do that, and we're not going back. Can't stop, won't stop. Let's put it right there for now. Can you make a mesh for the switch? You can. It can be anything. It doesn't have to be these cylinders. All right, we got a dead mesh now. So the way we are going to control our switch is we're just going to say like, hey, are you close to me? We are going to make the player interact with it, but to do the close check, we're going to use collision again. And the collision that we are going to use, I think, let's use a box this time. Okay. So where do we want to put our box here? Let's put it like so. And I want to see it in the world to understand how big that is. I think that is not quite big enough. Let's make it bigger. Need to close some of this stuff. Uh-oh, I opened the Epic Games launcher by accident. That's not what I meant to do. That's okay. Let's try doubling the size of the box in every dimension. That might be too big, but we'll check it out. And I want it to line up here roughly. That's probably good. Okay, great. So we now have a box sticking out. Another thing you can do, chat, is you can press the G key to toggle these gameplay overlaps. So like if you, or these gameplay visualizations. So if you don't want to see all of your like collision boxes and scene roots, you can just tap the G key and they'll go away. You can also rebind that, of course. All right, so now what we want to say is, hey, if a character is close to this box, they are eligible to interact with this. But the way that we are going to achieve that is not by just writing logic in the blueprint. Instead, I want to create two components. And I'm going to have one component be on the switch, and I'm going to have another component be on the character. And the way we're going to think about this is we are going to have an interactable, which is going to be the switch, and we're going to have an interactor, which is going to be the character. And in theory, we could have this interactable and interactor behavior be on anything, right? We could have a different kind of switch that exposes the same behavior. We could have other types of characters that can be interactors. We could have like a vehicle be an interactor. We can put them on anything that has the component that we're going to use. So let's go ahead and build those components. And to start with, I think they just need to be actor components. Let's call it BP interactor component. And BP interactable component. And they don't do anything yet. They're not real yet, but we're going to add them to their respective places. So on the switch, we're going to add an interactable, and we'll call it, we'll drop the BP prefix in our naming here. And on the character, we're going to add an interactor or a component. This is basically an interface, Shaggy, yes. We are giving behaviors to these actors without having to heavily modify the actors themselves. So let's think about what the interface for our interactable is. Well, I think the first thing we need to know is hey, can I interact with this guy? So let's call that can interact. That is going to return a Boolean. And in fact, actually, I don't think this needs to be a function. Probably an easier way to do that is just making it a variable, and we can make it public. Can interact. Or let's see. Yeah, can interact is good, right? By default, let's make this false, but I don't think it's going to matter. Then the next thing that we're going to do is expose a function called request interact. And we'll write a very small amount of logic here, which is basically like, can I interact? If so, we're going to call an event. Let's create an event dispatcher. So events are cool because we can bind against them in other blueprints. So we're going to say call can interact. So if it currently can interact, we're going to say do the interaction. And on the switch in its blueprint, we are going to hook up against that. So on begin play, we're going to bind event interact. Let's drag off of our interactable component. Bind to interact. So whenever that interact method gets called, whenever we successfully request an interaction, we will call this new event, which we can just write logic towards. And in our case, that is going to go to our garage door, which we need to check, is it valid? And if so, we're going to call toggle state on the garage door itself. That's what the problem is. Toggle state. There we go. Okay. So when we call interact on the interactable, we will toggle the state of the garage door here. This is going to get a little hairy, y'all, but it'll make sense, I promise. Now, the next thing that we need to think about is when can we interact with something? I think we're going to make it so that unlike our pressure plate, we are only going to toggle the state if the garage door is not moving. So the way we are going to achieve that is if we come back to our garage door, we need to publish some information about whether we are moving or not. And the way we're going to do that is we're going to have two event dispatchers. We're going to have movement started and movement stopped. And if we come to toggle state, we are going to say call movement started. So this will inform anybody that binds against those events that movement is starting. And when we end movement, we're going to say movement stopped. Just like so. Perfect. Now, if we come back to our interactable, we have a few more events that we need to bind to. I am on the component, not on the switch. All right, so we need to go to our garage door here again, and we need to bind to movement, bind event to on, or sorry, I didn't call it on. I called it movement started and movement stopped. So we're going to bind against that. Put him here for now. And we are also going to bind against movement stopped. Movement stopped. So now our wall switch gets a notification when the movement starts or stops on the garage door. Let's spread this stuff out here. And we're going to create a new event, and we're going to call this new event movement started. Let me zoom in here. I know this is small. We're going to write some logic there later, and let's create one for movement stopped. So when movement starts, we want to make sure that our interactable can no longer interact. So let's go to our interactable and we've already exposed our can interact. So we just need to set this to true or false. So we can say on our interactable component, set can interact. If movement is started, we're setting it to false. If movement is stopped, we're going to set it to true. So now our interactable is tracking whether or not it can be pressed. To review, what we've done is we've said, hey, when the wall switch begins, it's going to bind to 3 events. It's going to bind to the interact event on our interactable component, which is a part of the actor. It's going to bind to the movement started and movement stopped events, which are part of the garage door. When the garage door starts moving, we're going to tell the interactable, hey, don't let anyone interact with you. And when it stops moving, we're going to say, hey, you can let people interact with you again. So that will control whether or not something else can talk to that interactable. So the next piece that we need is we need to figure out what to do with the interactor, the thing that is going to actually push the button. If you want to show how to put mesh into Unreal Engine, you have one ready in Discord. Not tonight, Spy, but we can do that another time for sure. Basically, you can just import the meshes and they become static meshes in the engine. So the next thing we need to do is we need to know whether or not we're colliding with the box, because all of our interactors are going to be colliding with the box. And let's actually call this just box collision. So we're going to create the events there when we do the collision. We're going to do our same thing that we did with the pressure plate, where we do like the character check, we do all the standard stuff that we've already learned how to do. I think just this is what we need. I'm just copy and pasting here for speed. So if it's a character, actually, I don't even need to check that. What I need to check is whether or not get component by class. I want to check if it has an interactable component. That's what I want. I don't want to check if it's a character, because the entire point of this is it doesn't have to be a character. Then I don't want components. I want a single component. Get component by class. I called the wrong version of this. My mistake. How am I doing? I am doing good, Average Sova. We're writing gameplay logic tonight. We're working on that wall switch here. All right, so this is going to give us back that component if it exists. Again, we need that is valid check. It might not be valid here. And if it is valid, we're going to call code on it. And the code that we basically want to call is we want to tell the interactor that they are in range and can use the interactable when it's ready to be interacted with. So let's come over to our interactor component now and get that set up. Where did I put that? Here it is. I also need to save this just in case the editor crashes on us at some point. All right. So on our interactor component, we want to keep track of all of the interactables that are in range. And the way we're going to do that is we are going to have an array. That is going to be an interactor component. It'll be object references. And I can right click here to make it an array. And so an array is basically just a list of things. And in this case, those things are interactable components. The other thing I need to expose here is the ability to register and unregister an interactable. So when we get close to an interactable, we're going to say, hey, there's an interactable in range. And when we walk away from the interactable, we're going to say, hey, there's no longer an interactable in range. The way that we do that here is we just say, hey, on the interactables, let's remove item. And the item that we want to remove, we need to take in here. it is going to be an interactable component. Interactable component. There we go. Why is that not working? Object reference is not... Did I make it a by ref? That's a problem here. Why does it not want me to do that, I wonder? Let's try doing it this way. I think my array has the wrong type, but I'm not sure what specifically is wrong with it yet. Is it because Yes. All right. So I wasn't supposed to click object reference there. I had an array of references instead of just a normal array. Whatever. It's fine. We fixed it. Let's do input here again. We have an interactable. This time we're going to add it. Add unique, actually. We only need one copy ever. Okay. So on our interactor now, we have an array of interactables. So I'm going to show you what that looks like after I compile. I'm just going to set a breakpoint here. What I expect to happen is when I walk close to this, it's going to tell me, oh, hold on a second. I need to hook this up to my garage door. Okay, let's try that now. Nope, it's not working. So let's debug and figure out what I'm doing wrong. If I come over to my wall switch here, we are going to look and see if the actor has one of these. And if so, oh, I have to actually call the function we just implemented. That makes perfect sense. We want to register interactable and we want to unregister the interactable. There we go. Unregister the interactable. And the one that we are going to register is our guy. Cool. So now if I set that breakpoint, what you're going to see is when we walk over to it, we call it and we say, hey, I have an interactable. Please hold on to it. And when I leave, let's set a breakpoint on the leave function. The unregister function is going to get called here. Where is my game? Here it is. When I walk away, remove gets called. Great. So now the interactor knows what interactables are in range. And since it's an array, we can track multiple here. So if there are two switches nearby, we can find both of those switches and know that they're close. So the next piece is, how do we decide which one to interact with? For now, we're going to create a function called getBestInteractable. Or yeah, let's call it getBestInteractable. That's fine. We're going to look at our interactables. For now, we are just going to take the first one, if there is one. And to do that, we are going to do a loop. We will make this logic a little bit more sophisticated in a moment. But basically, we are going to take the first element that we see for now and return that. I need to set an output here. It is going to be a interactable. We'll call it best interactable. And we'll just have the very first call through the loop return it. In the future, we will add some logic here to decide what the actual appropriate one is. But so the point of this function is we're going to look at what's around us. We're going to find a switch that we can press if there is one. And let's say we're close to 3 switches. This is where we're going to write the logic to determine which one we want to use. So we now have a component that knows all of the interactables that are nearby. So on our third person character, what we now want to do is make it so that when you press a key, we try and find a switch to press. And if there is a switch to press, we press it. So the way that we are going to do that is we are going to wire up input correctly. First, I'm going to write a function here on our third person character. This function is just going to be called requestInteract. And what requestInteract is going to do is go to our interactor component. Our interactor component is going to find getBestInteractable. We are then on our best interactable going to call the requestInteract function on that. which, if you'll recall, I know this is a long journey, is going to call the request interact function on our interactable, which is then going to call the interact event dispatcher, which is then going to be picked up by our wall switch interact event handler, which is then finally going to call toggle state on the door. So now the only piece that is left to make this all work. Hey everybody, this is New breaking in from the editor booth to point out a defect that I missed on the live stream. Get Best Interactable might not find an interactable. It's possible there is no interactable. So we need an is valid check before we call request interact. Otherwise we could get an error. We need something to call request interact on our third person character. The way we are going to do that is we are going to just drop the function here. For now, we are going to use our same hack that we used before. We'll talk about how to do this correctly a little bit later. But for now, we're just going to do that. So when I am far away and press the F key, nothing should happen. When I move close to the switch and I press the F key, something should happen, but it's not. So let's figure out why. Let's make sure request interact is being called. Great. It's being called. Let's step into it. Let's see what's happening. We want to step in. We want to get best interactable. We're going to step in again. Step in, step in. Oops, I want to step out. Best interactable is currently none. Well, that's a problem. Why is it none? We have one. Nope, we did get one. Okay, it just lied to us, I think. All right, so now we're calling the request interact function on the interactable. We're going to check can interact. Ah, here's the problem. Can interact is currently false. That's the problem. So the reason it is false is because our default value is false and we never set it to true because we have never moved the door. If we stand on the pressure plate and cause it to move and then stop moving, I bet this works now. Resume. Yeah, so now it works. So that's our bug. Our bug is that can interact needs to default to true. Boom. So let's run this again. Let me clear my breakpoints real quick because we don't need these anymore now that we're confirmed that it's doing what we expect. So I'm far away from my door. I press the F key. Nothing happens. I move close to the switch. I press the F key. It opens. If I press the F key while it's moving, nothing happens. I have to wait for it to fully close because we set can interact based on whether or not the door is currently moving. Y'all with me? I know this is complicated, but we're almost there. So the next thing that I want to do here is I want to make the switch follow the inactive and active material based on whether or not movement has happened. So I'm going to do the same thing here around setting materials. We are going to set the plate portion of the material. We're going to say green is interactable, red is not interactable. Set material. And the asset we want to use is inactive, right? I forget which one's which. I think inactive is the one I want, but we'll figure it out. And then similarly, when movement stops, I want to set active. So why is this cool? Well, now let's say we come over here, we press the switch, it changes with us, right? Green means I can push it, red means it's currently moving. If I come stand on our pressure plate, you'll note that the color of our switch changes while the door is moving. And I want to slow the door down a little bit so that this is easier to see. We're going to change its default period to 3 seconds. We're going to see what our message log is mad about. Probably nothing because I fixed it all. As I stand on this, you see our switch is red. When it stops moving, our switch becomes green. When I move forward, I press our switch, it turns red. Our start state on the switch also needs to be correct. Let's go over to our same construction script here. And if the garage door is not valid, it will still be black. Otherwise, we are going to have its default be green. The other thing that is cool here is, let's say I create multiple switches. They are going to be synced up. So if I press one of these switches, am I up against the wall here? Not quite. If I press one of these switches, the other switch is going to disable. See? So now they're both red while movement happens. So now the piece that we need to figure out is how to select the best switch for our interactor to press. Because if I have two switches very close together, and if I have different doors controlled by those switches, we have a bug right now. So this one is hooked up to this door, and this one is hooked up to the original door. But what you're going to see is, since we're returning the first thing in the array, it's going to be the thing I get close to first, not the thing I'm closest to. So if I move up next to this switch first, the correct door is going to open and close. But if I move next to this switch first and then scoot over such that I'm colliding with both, but I'm closer to this one, I'm hitting the one behind me. And the reason for that is because in our find best interactable function, we are just picking the very first thing in our array. And if I set a breakpoint here, what you're going to see is that there are two components in that array because I'm hitting the collision for both of them. Does that make sense? You'll see there's two of them, so we're picking the first one, which is the one that we approached first. So what we want to do is figure out which one we're closer to and then make a decision based on that. In Valorant, you have X countdown before you can use a switch, like a Valorant bug when you try to pick up a gun when there's another nearby. Yeah, like, I think the way Valorant does that is a lot more complicated than just distance, but it's a similar idea. Basically, you know, we could do a lot of things. We could say, hey, which one are you closest to looking at? We can do distance. We can do all sorts of checks to try and figure out what interactable you want to actually engage with. So let's rewrite this function. We do want to return something. Let's create a local variable. So this is only in this function. We'll call it current best interactable. And we're going to say loop body branch if current best interactable, this should not be an array. This should actually just be a single object. If current best interactable is not valid, then set current best interactable to the current one. So the first one that we find is going to be our current best. Oops, that's not what I meant. I meant this array element. So that's step one. Step two is, if we've already got one, let's see if we're closer to the new one. So let's come out of our false branch here. And then we want to compare the location of the actor that owns this component. The way we get that is we call getOwner. And then we want to say how far away from you, from the interactable are you? And the way we're going to do that is, I think it's get squared distance too. And the thing that we want to compare against is the owner of the one that we are currently evaluating. So this is the distance from ourselves to the switch that we're evaluating. And we want to compare that to the current best. Current best interactable. All right. If our distance to the new one is smaller than the distance to the old one, we want to make the new one our new best interactable. So this is going to come out of our naive case here. And if it's true, we're going to set the current one to our current best interactable. Are y'all with me? Does this make sense? Or are you totally lost? Give me some feedback here, chat. I know this is getting quite a bit more complicated quickly. Sarand is with me. Okay. Clear as mud. Great. Excellent. Then everything's going fine. So we want to evaluate every single interactable in our array of interactables. If we don't already have a current best set, then we're setting. So the first one will always get seeded. Otherwise, we are going to check whether or not we are closer to the current interactable that we are evaluating versus the one that we've already selected as our current best. When we have evaluated everything, we will return the best interactable, which is our current best interactable. So that's our loop. And now we are making a decision based on which one is closest. It's a lot of if else. Yes. So one simplification I think we could make here. Let's make this a is valid. We can change the pins here. And this will simplify it a tiny bit, but not very much. So if it's not valid, we go ahead and just set. If it is valid, we come into this branch, we delete this guy, we delete this guy. We get rid of like one node, which doesn't help a ton, but you know, it's better than nothing. But we basically just need the first time we go through the loop to set the best interactable. Will I do more of these streams? Probably. This brings me back to gameplay programming in school in C++. Yeah, very similar. You can do all this in C++. I'm actually faster when I work with C++ than Blueprint, but this is still good. So let's see if we fixed our bug here. Now, when I come to that one first and move over, it should recognize that I'm closer to this one. And in fact, it does. We have done it. So the last thing that I think might be good to do here is let's change the color of our best interactable. And so the way we're going to do that, I think, is we're going to go back to our interactable component, which right now really just says, hey, can I interact with you? And we're going to say, what should we call it here? What should we call it here? Let's say covered for interact, selected for interact, let's say. Selected for interact and unselected for interact. And when we call this, we're going to again fire some events. Oh, I can't do that. I can't have a name. This name is my function. So let's just call it selected and unselected. And all these guys are going to do is call those events. Call selected and call unselected. And then we're going to come back over to our switch and we're going to bind against those events just like we did the other ones. I'm going to clean this up a little bit. So you can use what's called a sequence node. And the nice thing about a sequence node is if you're doing a bunch of things like this in an order, you can change the layout here. So let's change this and then we're going to sort our noodles. Spaghetti. Boop, 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 boop. Okay. So let's go ahead and move this all over here for now. This is one of the things that I don't like about Blueprint. If you want to refactor stuff like this, it's a lot slower than just moving text around. And then we can put our interact event right underneath it and run our logic there. Doop, doop, doop. That's all reasonable. We're going to move this reroute node down here. Then we're going to deal with our movement event bind. That will go there. We're going to put movement started over here. This will all look cleaner, I promise. Don't worry, it's going to get better. I'm just kind of grouping things based on where they go here. We're going to chase our spaghetti down. Okay, let's put that there. This can come up here, as can these guys. All right, so we've now done our bind for our interact. We're now going to do our bind for movement started underneath that. And I'm just trying to lay this out a little bit cleaner because I'm about to add 2 more events here, and that's going to get confusing if I was following the pattern I was already before. So here's our movement event that we previously wrote. Nothing's changing here. Then we're going to do the same thing for our movement stopped. Pull all this up just like we did before. So there's our movement stopped action. We need to bind that. And then we need to bind our 2 new events here. Let's go ahead and just delete this edge and we can just have another reference to the garage door here. Cool. So we need 2 more. We are going to bind to some more events on our interactable component. Let's move the collision stuff down here. We also, another thing you can do in Blueprint that's useful, especially as this stuff gets more and more complicated, collision triggers. You can add a comment describing what an area does on your Blueprint graph. All right, so we now have our interactable component again. We're going to bind to event selected. And then pull this down here. There we go. We're going to create a new custom event. We want to call add event, add custom event selected. Boom. There we go. All right. When we are selected, we want to set our material to, actually, we want to only set our material if we can interact. So let's actually capture this entire block. And we want to call get can interact. If it's selected, and we need another variable here. Let's call it our selected material. We're going to wire this up. And I think we made a yellow one earlier. Let's use that. I don't think we've used it yet. We did. So now, if we can interact with it, you know what? Actually, I don't need to check this here. This is not where we should be checking it. We should be checking this on Find Best Interactable. This is wrong. Let's fix that. So we only want to set this if the current element is interactable. B can interact. Why is that not working? Get can interact. There it is. All right. We need a branch. We're going to do all the same stuff we were doing before, but only if it's interactable. So let's spread this out. And this just saves us having to check that in our selection logic, because we're not going to select something that we can't interact with. That's all we're doing here. That should work. We'll check it. We'll debug it if it doesn't work. Okay, so now we know that selection is only going to be invoked when we're actually selected. We're going to set our material to the thing that we want to. Great. When we are unselected, we're going to clear it. Bind to event. Unselected, custom event. What do I rename it? There we go. Unselected. And then we need to actually check whether we can interact this time. I need that to be a get. And if that's true, we are going to set it to the active material, right? Right. Yes, when we set can interact, it needs to be the active material. And if it's false, we need to set it to the inactive material. And again, we'll clean up the spaghetti here in just a minute. Okay. I think that logic is all correct. So now what I expect to happen is when we get close to one and we say it's the one we want to select, we're going to make it yellow. We're going to need to start checking this whenever we move, which means for now, we're going to do that in our tick function on the character. Or actually, I guess we could probably do it on the component itself. Because right now, these events are never going to get called until we actually try and do the use. What's it upset about? Target must have a connection. Target should be connected to plate because that's the thing we want to change it on. Cool. I think that'll work. If I come over to my interactor now, and if I go to my event graph, we now are going to add a tick function. Don't need this here. I do need current best interactable. Why is this upset? Let's try this again. I want a variable. Current best interactable. I'm not sure why it's not letting me name it that. Let's say best interactable. There we go. I must have had a naming collision. That's okay. On our event graph, we need tick. And on our tick, we're going to say get best interactable. And if branch, if best interactable is not, let's call it selected interactable. If it's the same, we don't need to do anything. If it's not the same, then we need to, on the previous interactable, tell it that it is no longer the best interactable. So we want to call unselected. Then on the new interactable, and we're going to wire this a little bit more cleanly. Wire there. Put another one down here. So that means we are no longer selecting the old one. We do need a pin here. We need to set the best interactable, or set the selected interactable now, either after calling unselect or after seeing that we don't currently have one. And again, we'll clean this up a little bit. And the interactable that we want to set is the best interactable that we just found. We'll pull that down here. Then we need to tell that interactable that it is selected. And I think that'll do it. Let's see. Let's see. Hopefully, when we walk near one, it turns yellow, and it does. Uh-oh, it didn't turn back when I walked away. So we still have a bug. This one turns yellow, then this one turns yellow. So now we need to figure out why we are not returning. We can check that here. If we go back to our switch, let's first check that our unselected event is ever being called. If not, then our bug is upstream. It's not being called. Access none trying to read selected interactable. Well, that's our bug. So why is that true? Let's debug. So when we first come through, we are setting the selected interactable. And the selected interactable we said is the one that we're near. That's what we expect. We walk away now. We get this is valid check. We have a reference. So I expect we're now going to call unselected here. But let's see. We step into it and nothing happened. Why did nothing happen? Am I calling the wrong function? Let's check what happens over here. So that's on our interactable component. We have unselected, which calls unselected. Aha, selected. Oh, hold on a second. Selected. Oh, I see. Hang on. We shouldn't be calling directly like this. I should be calling the functions. Need to stop my session here. Unselected. Then selected for interact. Let's see what this does here. We're going to walk close. Yep, it's still valid. We walked away. Now let's see if this calls the function we expect. All right, it calls the function, which then calls the event. Did I mess up my event binding? In my wall switch here. Bind to event unselected. So this still is not being called. I forgot to wire it up. That's why. That's why. We got it, chat. Did you know that if you don't wire up your binding, you don't bind your event? For real though, like this is what game dev is often like. You're like, I know this should work. I'm not crazy. All right, now, all right, let's clear our breakpoints. We don't need these anymore. I'm pretty sure this is gonna work. So when I walk away, it turns back to green. We did it. We did it. We did it. Everything's fine. All right, I think these errors are all fake now, but let's confirm that that's not true. I might have messed something up still. We might have a none check. We do have a none check. Let's look at where it is. I clicked the wrong piece here. Ah, I see what's going on. No, if it's not valid. All right, where exactly is it? Access none, trying to read property selected interactable. I just said it. It shouldn't be none. Aha! I can't set it if it's none. That's why. We need another is valid check. Because when I walk totally away, there's nothing to set and we're done. There's not guaranteed to always be a selectable interactable. And this node should now go here. Cool. I think that'll get rid of our error, which wasn't fatal because we're writing Blueprint, not C++. Okay, it only works once now, which is not what we want. So why the second time is it not working? You with all the anim blueprints you work on? I mean, like, we're getting way down in the weeds here, right? But like, y'all understand. You'd love to see some things in an animation blueprint? We could maybe do that sometime. So let's figure out why our second selection isn't working. And then maybe call it a night. We should see the selected event get fired twice. Once when we come in. I thought we would anyways. Did I actually forget to set it? Let's do this. Let's try it one more time. When we select it, why is this not getting called? It's clearly running. It's clearly running. I'm not crazy, chat. I swear I'm not crazy. Save everything here. I know I'm not crazy because it did get hit once. We saw it. We saw the selected material get applied. Hey everyone, editor new again. The reason my breakpoints aren't being hit is over in the top right, you can see that I have a debug filter selected, which filters the debugger to only consider one instance of the actor rather than all instances of the actor. I didn't intend to set this, and I didn't notice it during the live stream. It turned yellow, but my blueprints aren't being hit, or my breakpoints aren't being hit. Well, that is pretty interesting. Let's try it there. See what happens. All right. So I have an interactable. When I come here, we have a target. We're going to step in. That's going to call selected, which calls here. I don't know why our breakpoint wasn't hit. We're going to continue to step in, and we are going to set the material. Great. That all makes sense. Now, the next thing that we expect to see is when we walk away, we're going to call unselect. Let's make sure that's still true. We call unselect. We should see that step in. We hit the unselect event. Then based on that, we're going to set our material again, right? Yep, that's all good. That's what we expected. And we forgot to clear it out. That's why. So we're calling unselected every frame on it. We need to clear it out if our new best is not available. So really, what we need here is to check this after the set, not before the call. Let's do this here. Hook that up there. Hook this up here. Move this here. Move this here. Move this here. Delete this. If it's valid, we call selection. If it's not, we do nothing. We're going to clean up this junk. And this can come down here. We'll make another reroute node just so that it's clean. Why is it upset here? Okay, everything's fine. We're just messing with some spaghetti. This is just like relaying out all my conveyor belts. Okay, does this do what we want now, chat? I can clear these breakpoints for now. There's the set. We walk away. There's the unset. And then we set. Then we set again. And it's yellow again. We did it. We did it. Heck yeah. All right, my friends. We now select the switch that's closest. We can select it multiple times. When we press the button, it is synced to the buttons around it if they're bound to the same door, because we trigger based off the door's movement. So when I press this one, both of these switches are going to turn red. When I press this one, it's going to turn red. When I step on this plate, those two are going to turn red. Everything is working exactly like we expect. It only took us a half an hour longer than I expected. So let's review what we did here, just because that got a little bit more intense than I anticipated. Our wall switch is bound to the garage door. The garage door, when it moves, tells our wall switch, hey, you can't interact with me right now. And it does that via the movement started and movement stopped events. We also change the material accordingly. Our switch also has an interactable component. That interactable component exposes 3 events. 1, interact. 2, selected. 3, unselected. Something not defined within the wall switch class itself can talk to the interactable to trigger those events, which then causes our wall switch to take actions in response. In the case of the interact event, it will try and toggle the state on the garage door. In the case of selection or unselection, it will change its color based on the current state. The final piece of the wall switch is we have a collision trigger, and when we find collision with an interactor component, we wire up our interactable component to that interactor component. Looking on the other side of the house, we have the third-person character who has the interactor component. The interactor component keeps track of all of the interactables that are in range of it via the register interactable and unregister interactable functions that are called by the collision with the box volume on the wall switch. It also has a function called getBestInteractable, which looks at the distance of all interactables within range, checks that we're eligible to interact with them, and if so, keeps track of what the best interactable is. It also does ticking to find the current best interactable every frame. When that changes, it unselects or selects, calling back into the wall switch so that it can change its material. Probably a very minor improvement we could make here, which I'm not going to make, is there's no reason to call getBestInteractable when there are no interactables. We could maybe pause ticking. We don't need to worry about that for now. The final piece is to drive the interaction. Our third-person character currently calls the requestInteract method on the interactor component, which talks to the best interactable it is tracking in its registered interactables, which is associated with a wall switch, whose event then triggers toggle state on the garage door. Now, I did mention this key binding is not the right way to do it. Thank you for keeping me honest here, Shaggy. Let's talk about how to do that correctly. I'm going to go super fast here, but in general, it's usually better to do input control in your player controller rather than directly in your characters. And we can talk more about the distinction between player controllers and characters later. But instead, let's look at the full path of how we actually set up input properly. First, in our project settings, we need to look for input. Not gameplay debugger, actual input. Sometimes the search doesn't do exactly what I want. We're going to find it. Engine input. Here we go. Right now, we've only got one action mapping that we're using, and that's jump. We are going to add a new action mapping, and we are going to call it interact. By default, we are going to bind it to the F key. Great, that is done. Now, how do we get that to our character? Well, let's delete this first. That's our hacky solution, which we're not going to use for real. The next thing that we need is a player controller. By default, you have a game mode that is associated with either your project or with your map. Right now, our game mode is the Kilwalla Crew Treehouse game mode. This is a C++ class that was generated for us when we created our project. That's fine, but the problem is we have all of our actual options around the controller type and the pawn type grayed out. We want to be able to change those. To do that, we are going to create a blueprint instance that inherits from the C++ game mode. Again, I think we can go into the details here more in another session, but for now, just roll with me here. We're going to create the blueprint instance of our game mode, Kilwala Crew Treehouse game mode. Okay, great. So we now have our own custom game mode type. Here we can create our own controller type and change all of these settings. We are also going to go ahead and create a custom player controller. We're not going to do anything special in it yet, but we will. We're going to call it BP Kilwala Player Controller. Maybe someday we will make our pawn a Kilwala. That would be pretty rad. We are going to change the default controller that we want to use to our controller that we just created. Right now, it has no logic. It just calls into the base player controller. Over on our project settings, we're now going to set our mode to our blueprint mode that we just created. You can see that also took our controller setting. So at this point, we are now calling into our player controller. Our player controller in the event graph has nothing. However, we can say when the interact input is pressed, we want to look at the pawn that we are controlling. I forget the name of the function for that. Is it player pawn? No, I don't want by index. I think it's like controlled pawn. Get controlled pawn. There we go. So the controller controls a pawn. You can think about the controller as like the brain that is driving the pawn. The canonical example is you have a player controller, which might be a player pressing keys on a keyboard or on their controller. You can also have an AI controller, which doesn't need a physical input device, but can still drive the same pawn. So the reason it's useful to do the input control here in the controller is if I wanted to write an AI that knew how to interact with buttons, it would all look the exact same, and the controller or the actual character, my pawn, doesn't need to know anything about physical input. But again, this is a broader topic. We'll go into it more in detail later. We get the controlled pawn, we cast it to our character type, which is third-person character that came with the project. We haven't changed it, we just modified it. If that succeeds, we then, on third-person character, call the interact method. Woo! And I think we are almost there. So on third-person character, let's see here. Yep, request interact, which then calls through to our interactor component, which then calls through the entire chain. So let's see if that works or if I missed a step. Huge success. Got it in one. So at the start of the game, the engine creates our game mode. Our game mode is Blueprint Kilwala Crew Treehouse. Our game mode specifies the controller target, and then the engine creates that controller type, which in our case is Blueprint Kilwala Player Controller. The controller then possesses our pawn, which is of type third-person character. Our key binding is understood by the player controller, and it drives that action into the third-person character, which then makes a request to its interactor component, which then makes a request to the interactable component receiving the interaction request, which then on our switch is picked up via an event, which then causes the garage door to move via the garage door's toggle state function. And we're done, chat. Any questions? Now save before Unreal crashes. Congratulations, you're all gameplay programmers now. We sort of went from like a very simple example to something a little bit more complicated than I intended to share here. And thank you all for bearing with me through the debugging. That was a little bit more intense than I expected. But that was fun. At least I had fun. Did y'all have fun? Oh no, Sarand is a gameplay programmer now and can't do tech art. Yikes. You're lost, you don't know C++? Well, we didn't do any C++ tonight. I will cut this up into a VOD so that it's easier to jump around and figure out what's going on at your own speed. But I hope this was useful, y'all. I hope this was useful. All right, it is 10:20 right now. So I think I'm gonna play like a couple spy crushes and then call it a night, y'all. I think that's gonna be my plan here. Let's close and save everything and make sure that I commit it back to my source control. Create garage door, pressure plate, and wall switch. Done, y'all. Let's fire up Valorant. Let's chill a little bit, and then I'm gonna go to bed. I hope y'all had fun. I had fun.